All right, let's start. Okay,
Uh,
so
Sorry to cut you off, but so
all
William,
good.
are you recording the lecture or do you want me to record?
Yeah, I just started it.
Okay.
Let's see. Okay. All right, so 212, just go full screen. 212 is all about or object-oriented programming Java. We're studying for exam 2. Here are the topics. Um, we have linked lists, interfaces, inheritance, abstract classes and methods, and event-driven programming. So this is a practice exam from a previous class, so I guess we'll just get started on the first question, linked lists. So assuming a singly linked list with head node containing social security numbers, as in the lecture on dynamic structures, has been created correctly, write a method for the SSN list class that will print each SSN in the list to the system console. So linked lists, as we probably know, in a linked list you have nodes, and in each node it has a pointer to the next node as well as a value. So for the SSN list, you have SSN list. So for this class, it is a linked list class. So it has nodes, and these nodes are indicated by the class SSN list node. So when we're writing this for this question, we want to print each SSN in the list. So we want to go through each linked list node and then print the value. So let's code that. Where's this eraser? Okay. I guess I'll just write it. I want to erase that. Is this a thing? Oh, cool. Okay, so we're creating a method. So we start off with uh, divisibility, which is public. And then it doesn't return anything since we're just printing to the console, so it's void. And then the name could be anything. We'll just name it print nodes. And we want to take in a linked list, which is SSN list. We can name it anything, my list. So now we want to iterate through all the nodes and then print the value. So to do that, first we want to start off with the root node. So let's define the root node. You can name it anything like this. And then this could equal this list dot next. So we want the first node in the list. That, or alternatively, sometimes it's called root. I'm not sure what the professor implemented in his class, but we can go with this for now. So now we want to do a while loop. We want to go through keep iterating through the nodes until the last node points to null, essentially. So we want to do while p does not equal null. In this case, we want to print. So system out print line. And the value, so the node value, so p.data. And then we want to go to the next node. So we do p equals p.next. So while this while loop keeps iterating, it'll go through each node one by one. At the point where it says p.next and it reaches null, it'll break out of this while loop and we're done printing all the node values. So that's question one. Feel free to leave any comments or questions if you have any. Just question two, interfaces. So you have an interface, exam two, with the methods get answer, get string, a class that implements the exam two interface. What methods must be declared in the exam two class? So as we know, for interfaces in Java, if the methods in an interface are not default, so default like this, then you have to declare them in any class that implements that interface. So in this case, we see get answer and get string are the two methods declared in the interface, and they're not default. So we must declare both of those methods. So the answer would be get answer and get string. Question part B. Uh, so in this case, get answer is, let's see, exam two class extends exam two super, and it also implements exam two. What methods must be declared in this class? So this interface requires the methods get answer and get string, and exam2 class extends this class, which already has the method get answer. So in this case, we only need to implement get string, since the parent of exam2 super already has the method get answer. So this would be get string. And if you wanted to, in this exam2 class, you could also override get answer as well, but it's optional. Okay, so question three. Let's get try to move these guys. Okay. Examine the code below and answer the following questions. A, provide a get method to be inserted after line 13 for the value of species. So line 13, this is line 13. So is that okay? A get method. So a get method, so you probably know, we want to get the value of species. So species is a variable, instance variable in our class animal. We want to create a getter. To do that, we just do public. Get methods are usually public. And then the return type is the value, the type of the variable, which is string. So we want to return a string, and then we can name it anything. We can just get species, and then we just return species. We could do this dot species. You don't have to write this, but it's like good practice because we're referring to this object. Okay, so part B, provide a set method for the instance variable population, which does the same error checking as a constructor. So let's see. Now we're dealing with population. We want to set the value, and we want to do some error checking in the constructor. So in the constructor, how do we set population? We set population to P, and the error checking on P is this. So if P is less than 0, we don't want to throw an error. So let's write it over. Where can I write this? Just right here. So a setter is void. So we want to do set population. We want the new value of the population. So int, because population is an integer. We can name it p. So we want to do error checking. So if p is less than 0, we want to throw this exception. So same thing. That's the constructor code. 0. We want to throw blah, 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 blah. Whatever was written in here. Population cannot be negative. I don't want to write all that. And then we can just do this dot population equals p. So we're setting the population value to our new value of p. Switch that. Okay, so let's see. C, write a class flying animal exception, which is an extension of a legal argument exception. So when we're creating a class, we always do just start off with a public class. And then it's called flying animal exception. And it says an extension of the legal argument exception. So we want to do extends a legal argument exception. And since the legal argument exception has a constructor with an argument, we have to override it. So we want to do public like animal extension exception. And the legal argument exception has a constructor with a string. So we want to do string message. Jesus. And then super. So yeah, any questions so far? Okay, we're good. Let's get this. Huh, sure. Okay, so question part D. The instant serial wings beats per second in the abstract class flying animal must be greater than 0. Complete the if statement on line 20. Uh, line 20, this guy. So that an exception is thrown with the message wings beats must be greater than 0 if it is not. So you need to just fill this guy in. So we want to check that the wing beats must be greater than 0. And if it's not, then we want to throw an exception. So this is a conditional. Wing beats is given by the integer w. So we want to check if w is greater than 0. And we want to check if it's not. So we want to invert it. Why is that a diamond? Okay, so we can do De Morgan's. We can either do just flip the sign and add an equal sign, or we can do w is less than 1. Either of these conditions are the opposite of w is greater than 0. So to fill this in, we can do, get right over here, if w is less than or equal to 0, then we want to throw a new flying animal exception. Blah, blah, blah. With the text, wing beats must be greater than 0. Just pass that in. We get the gist. Right, yeah. Yeah, that's good. There's a part E. There's a part E. Provide the proper arguments for the supercall in the single argument constructor in line 32 so that the default values from the interface are used for the remaining parameters. Okay, so we have a supercall and we want to pass the arguments. So let's see, bird extends flying animal. So what are the arguments for flying animal? If we go into flying animal, that's this class. The arguments are string, int, and int of name, population, W. So we need to somehow pass in a name, population, and W. But the question also asks, or tells us to, use the default values from the interface for the remaining parameters. So we're only given species, which is the name. And we want to use the default values from the interface, which is implements flapping. So these are the default values for the remaining parameters. The remaining parameters being population and W. So to pass that in, we just use species. And then the default values, so flapping, we can do flapping dot population, default population. Population. And then default wing beats. Yikes. Is that is that readable? Yeah, no, that's pretty good. Okay. So yeah, just to reiterate, we're matching super, a flying animal, which takes in a name, which is the species, population, which is a default value of inside flapping, and same for the wing beats. Uh, Okay. Question 3, question 4. Any questions for anything so far? Okay, we're good. Question 4A. Continuing with the set classes above. Okay, so we need to use all these classes. What will be the output of the application above for each given value of statement 1? If no value is given, assume the statement is blank. If either statement will cause a compiler error, explain why. If no value is given, assume the statement is blank. Okay. So statement 1, Igor. So, okay, so this statement comes in here. We're defining Igor to null, a new bird of Robin, a flying animal finch. Okay, so Igor equals new bat, vampire, 1230 will be the output. So let's try this. We're creating a new bat. So we want to go into the bat class. We're passing in string int int. So we use a string int constructor. So string int int. Oh, it's a Boolean. No, not that one. Bat. This is, yeah, bat. So that should be a compiler error. But if no value is given, assume the statement is blank. Hmm. No value is given. Okay. So the answer key says it's not a compiler error, but this should be a compiler error. But I think there's something with this statement. Assume the statement is blank if no value is given. Let me think here for a second. What does that even mean, bro? If no value is given, assume the statement is blank. Sure. Okay, but that's a compiler error because there is no constructor with the parameters that take in a string int. We have a string, wait, and we have a string int boolean. There's no string int, so that's a compiler error. Um, error, and then the reason could be uh, no no constructor matching. And then we could do string int statement or part B. So now we are passing in an actual Boolean, so that's correct. So we're going to call the constructor string int Boolean, which is this guy. So if you just follow through, first we enter here, it then calls the super. So super is flying animal. So it goes into flying animal. This is extremely hard to read. Just scooch that over. Flying animal, it goes into this constructor, and it calls super, which is animal. So now we're going up a level even more. So now we're in here. What were our values? It was null, 1200, 30, and false. So null, 1200, and 30 pass into super. So it's null, and 1200. Just double check. Okay, species, it's okay, that's good. So now we're in here. So if it's null, it throws an exception, which is a runtime error. The output would be uh new the exception, so invalid animal exception. And then the message is species must be given. And then since we're in the main, I mean you could also add exception in thread main. So just add that. It's usually how it looks. And all that. Okay, that's good. So statement C, now we're given a string that is not null, int and boolean. So we can just fall all the way up here. So string is not null anymore. Is p less than 0? No, it's 3000. So now we're in here. We set it to, I already forgot what it was. Robin. And then 3000, then we print out new animal species is robin population 3000. New species is robin. Population is 3000. So after we're done with this, we want to go back up a level. So we were just over here. So now we will do this if check. What was it? If W is less than or equal to 0, W was 30, so that's false. So now we set many beats per second to 30. We want to go up a level again because we're done with this super call. So now we print out this. So this a toString, uh, toString. So this a toString. It's not in here. Check our parent class. If it overrides it, it does. So for this class of bird, it'll return this class, which is bird in this scope, not get name. So it would be bird created species is robin wing beats equals 30. So bird created species is robin wing beats. Is that equal? Equals 30. Okay, that's part C. Now part D, robin equals new bird of robin. So go into bird. Bird class of a string. So we're just giving a string. And what do we write here? We use the default parameters. So we called super on flying animal. It's robin. So currently it's robin. At this point in time, we pass in robin and the default parameters, which were 10,000 and 30. So we go into the super call. Super is animal, so we go to the animal class. Just get rid of that. So we're in here, string equals null, false, false. Skip that. 30 is greater than 0, so we skip that. So we set the species and population, and then we print. So we're going to print out new animal species it was robin, and then population was 10,000. Population. Yeah. So new species, robin, population is 10,000. Just double check this. Uh, Population 10,000. Okay. Now we check this if statement. It was W is less than 0. W is 30, so it's false. So we set the wind beats per second. We go back up to where we called bird. We called this constructor, and we do nothing after it. So that's all that gets printed. So for number E, Igor equals new bat of empty string 20 and 25. So bat, we got empty string 20, 25. that is the same thing as this guy. So it's the same error. Let's copy that. What the hell? There we go. Okay. Part F, Finch equals new flying animal, Finch 5045. So flying animal, just scroll up flying animal. Was Finch 5045? Yep, 5045. So first we call the super, which is animal, pass in Finch, then 5000. Check these statements. It's false, false. So we're going to print out this guy. So new animal, species is Finch, population 45. New animal. I feel like new species. Okay, these might have been. Anyways, species is population 45. The animal Finch. Population is 45. Um, for these guys, it also should have been new animal, new species. So whatever that print statement says, just add that in. Yeah, so then we're finished with this constructor. So we go back up into here. The estimate if W doesn't equal to 0, W is 45. That is false. So we just set it. We set it here. New flying animal. So that should be it. Um, actually, let me check. Shouldn't that extends animal? Implements flapping. That should be a compiler error, actually. What the fuck? I mean, what the heck? Because you can't instantiate an abstract class without overriding its methods. Let me just double check. Calling new flying animal with an abstract class, which extends animal and implements flapping. Flapping declares these two methods, wing beats and flaps. This method does not. I don't know. Is it a trick question? This should be a. This shouldn't even compile. Okay, I'm gonna revise my answer. Compiler error. Um, cannot instantiate abstract class without implementing its its methods. That's, yeah, interesting. So let's just get rid of that. This might be a trick question. I don't know. Like, yeah, I don't think you're expected to know that. Um, now I gotta check these other guys. Wait, new bat. Okay, that's implemented. New bird. That's fine. It's not abstract. Okay. Yeah, so F is actually a compiler error because you're instantiating an abstract class, and if you're doing that, um, it's usually fine, but the syntax would be something like uh, new flying animal with constructors, parameters, and then you would do this, and then implement these guys, wing beats and wing and flaps. So this part would be put in here essentially. So override, add override, and then those methods. So yeah, that's a compiler error. Any questions so far? Or else I'll move on. Okay. Question 5. That's question 6. Okay, question 5 is over here. J-frame. Hate this. Okay. So the following code is meant to create a new GUI, J-frame, with one menu called exam2, which has two menu items, pass and fail. Write the proper code for each of the missing pieces in the box to the right. Okay, so for number 1, it would be J-frame. You just have to know that from your labs, I suppose. Let's see. So number 2, we're creating a private instance variable, the name main menu bar. Main menu bar equals new J menu bar. So we're going to use the type J menu bar. Part 3, J menu. Uh, that's a variable name. It could be anything, but let's see if we ever use it down here. J menu. Exam2 equals new J menu. Okay, so the variable name is exam2. So we do exam2. Number 4, we want a class with a and the variable names are mpass, mfail, and number 5. So mpass, what is mpass? Mpass equals new something. Let's see where this is used then. Okay, mpass is used when we're adding to a J menu. So we call jmenu.add and we pass in a J menu item. So the type is J menu item. And that's the same thing for number 7, so I'll just fill that in. Number 5, it's a variable name. So mpass and fail. So we did mpass and fail and then mquit. What the? Okay, mquit. Yeah, it's good. Number 6, so we're looking for a class name. Exam2 ML, where's that used? here. Exam 2 ML equals new something. So 9 and 6 are going to be the same, or no, unless it takes in a parameter. So the type of the class would be, okay, where's M2 used? MPass, which is number 7, a new JMenu item dot something exam2 ML. Am I missing something here? Okay. What could that be? So it could be if we're calling a method on a JMenu item, we want to attach a listener. ML could stand for um, likely listener. I think these two questions are connected. So actually, we're going to use the exam2 listener. So exam2 ML type would be exam2 listener. Yeah. Well, I'm not sure if you should use something from the question following, but I think that's what the professor wants. But in any case, so for number 9, we can fill that in. So we're creating a new instance of the class. So we do new exam2 listener. And then the parameters. What does this take in? It takes in a main window F, so we can do this. Since this is a main menu. Question part number 8. Main menu bar dot add. What are we adding? We are adding to the main menu bar a J menu. We add a J menu to J menu bar, which in this case is exam 2. So yeah, because the question says one menu called exam 2, and we want to put that in this J menu bar, and then display the whole thing. We're setting the main window menu bar to that main menu bar, and we need to display exam 2 somehow. So it's going to be in the main menu bar. Little, yeah. And then number 10, since this is an action listener, as you probably know from your labs, the method to add an action listener is add action listener, and the parameter is already given. We're passing in the exam 2 action listener. So following suit, since we know this is a action listener, number 1 is action listener. Number 2, mainframe. Mainframe equals F, and F is main window. So number 2 is main window. Number 3, it's a method name. The method name, since, okay, this is the whole class, and we're implementing action listener. I believe the action listener has a method called action performed, which you need to implement since it's an interface. So this would be the override for action performed. So number 3 would be action performed. Number 4, chosen item is a string and equals another string of something. I should have probably read the question. The following code is a listener for the GUI. Okay, that's hint at number 1. Oh, in the question above. So what, you had to like not know number nine and then six and then do question six and then go back to question. Okay, whatever. If the user chooses the menu item pass as a message saying hooray, you pass should be printed to the console. If the user chooses fail, then we print out too bad you failed. If the user chooses exits, then we terminate. Okay, so hooray, you passed. We want to make when we do that, the condition is pass. So this would be pass. Number five, it says in the question, when you choose fail, we want to print out this string. So this should be too bad you failed. The period. I believe that's it for this ethics exam. Any questions in general about the question? Anything? What are you supposed to know for a linked list? Let's see. So here you go. Take a screenshot or whatever. So define a list node. List node. Just switch that. Actually, do you want me to go over all of these? Or is the just knowing the topics good enough for you guys? What do you guys think? Okay, go over it. Okay, so we want to define a list node. Um, as we know, a linked list is like in this structure. This whole thing right here is a linked list. And these are nodes. And these nodes are connected by pointers to the next node in the linked list. So a linked list has a head node. That's it, actually. And a size counter, I'm pretty sure. Yeah, but I guess don't worry about that for now. So a node has a pointer to the next node and a value. So I guess I can write in here node next and then int value. Of course, it doesn't have to be an int, it could be a string. It could be whatever you want. But in the actual code, if we write the class for node, it would be public class node, and then we could have node next, and then int value, and then a constructor to initialize that. So that answers define a list node. This is basically it. So in our linked list class, we have public class linked list. We simply just have a node, which is the head. Same thing right here. So we only have in our whole linked list a head, this node right here. And then using that node, we can get the next node by doing head dot next, which points to the next node. And then using that node, we can do dot next again, which points to the node afterwards. And this keeps going until it basically points to null. So that's what a linked list is. Um, that's general linked list stuff. Before the topics, define a single linked list with a head node and a counter. So we did that over here, a head node, and then a counter, I assume that's a size. So we can do int counter. And the counter basically is the number of nodes in our list or the size. So in this example, we have 1, 2, 3. But yeah, but the problem, wait, is that okay? Because what I'm thinking right now is like when we add to the linked list, we can just do counter plus plus. But if a node somehow we point it to null, we need to update the counter to remove all the guys. Define a single list with a head node and a counter. Okay, I don't think they care about the implementation details, just the class definition, which is basically this. Okay, yeah. And then be able to traverse the linked list from the beginning to the end. And for example, find a given node, print the data in the node. The counter is just the length. Yeah, I assume that's what that means. A little it should say size, honestly, but yeah, I don't see what else counter could be unless it means the node has instead of int value, it's int counter. But assume it's a size for now. So that's that. Let's move all this. Be able to traverse a list from the beginning to the end. To do that, we just take the head node. So as we did in, um, I guess that whatever I wrote was gone. Unlucky. So to traverse, we have, let's say, we're given a node. Let's just say it's a head node, and it equals new node or something. It's given. Assume it's given. Um, so we just need to do while head does not equal null. Actually, this might be a little unclear. Let's just do this. Node n equals head. So we're starting with the head node. We're putting it into a variable n, and then in our while loop, our condition would be while n does not equal null. Then we want to um, find the given node and print the data. So we want to do if node. We can do target. Let's say we have some target node. So we want to check if it is, we want to find the given node. So we want to check if n is equal to the target. Print the data. But if you already have the node, we already have the target, why do we need to traverse? Wait, this is just very convoluted. Wait, traverse the list from the beginning to the end. So let's just first traverse it from the beginning to the end. Let's just do that. So let's just say print, system.print, the drill, v.n.val. And then we want to set n equals n.next. So this basically goes, we start at the head, and then I guess I'll put n right here. So n currently points to the head. N does not equal null. Let's just say there's a bunch of guys, and then this points to null. Well, n does not equal null. Since that's true, it points to the head. We want to print the value. Let's say the value is 10, 5, and then 2. So we print out 10. Then we set n equals n.next. Since this is n dot next is this guy. So now n equals n dot next. We go back into the loop. While n is not equal to null, it's true. We print the value, which is 5. N equals n dot next. Same thing. N does not equal null. Print the value is 2. N equals n dot next. And then while n does not equal null, n is null, so we break. So that's going from the beginning to the end of a linked list where we just iterate through each node. And then we can perform actions like printing the value or whatnot. So the question is also says find the given node and print the data in the node. Now, find a given node. To find a given node, we need some condition to check if the node is our given node. That could either be if we're given a target node, we want to check if current node n equals to target. That could be one condition. Then we could just print, as it says, the data in the node. So n dot data or n dot val. But I thought like before, like what I was thinking of, like we already have the target node, so we can just do target dot data. Since we know at this point n equals target, so I don't know what the point of is checking all this and going through the whole list. But yeah, maybe I'm missing some condition. But who knows? So you'll just put in here if condition, that's your matching condition. And then I want to print. That's the structure, but we always have n equals n dot next. If we don't have that, then this will go on forever, since we're just stuck in like this node, for example, and n never gets updated, and it's never null, infinite while loop. Okay, so append a new node to the end of the list. I forgot. In a linked list, we also have a node of tail. Now, you could, if you have a tail variable, tail basically just represents the last node in the linked list, which always points to null. If we add a new node to the end of the list, then we simply just do tail dot next is equal to our new node. So let's say we have a new node here. This is our tail, our last element, our tail. We point it to here, and then we have to update our tail. So we can do new node. Oops, we can do tail equals new node, assuming this node points to null as well. Let's say we're also given, we're two linked lists, for example, and we want to add this guy to point to this guy. So our tail, if we just set tail to new node, then it doesn't point to null. So what we have to do is do tail equals um we can either one iterate till the end of the new node, or two, we are given a linked list. What I mean by that is we have one linked list, we're given another linked list, we want to connect those two. So this tail connects to this head. In this case, we can just set the tail to equal the tail of our second linked list. Set the tail to the given linked list tail. Set the tail to the given linked list tail. So this guy is our new tail. But let's say our linked list doesn't have a tail um, variable. What we have to do is we have to start from head because we have nowhere else to start. Then we do our while loop. And then inside our while loop, it goes until n does not equal null. It goes until this point. But we need to stop before that point. So it's getting a little messy. While n does not equal null. First, before setting so n, first it goes here, then it goes here, and then it goes here. And the while loop stops. Before it goes to here, we want to check if it's null. So if n.next is equal to null, that means our currently n is here, and n.next is null. So this is our last node. So what we can do is simply n.next, we set it to our new node. Our new node, let's say it's this guy. So we set n, which is this guy, to next to this. And then we still have n equals n dot next. In this case, since n is now this guy points to null, n equals null, the while loop breaks, and that's how you add it, given just the head. Okay, just put that in there for now. Okay, so insert a new node after a given node. What does that mean? Okay, we're given these guys, for example. We're given this node. We want to insert it. Let's say we want to put it like over here. So this guy would point to our new guy, and our new guy would point to whatever our old guy was pointing to before. So to do that, first we need to start at the head and then go node by node. Now, what are we given? We're given a new node, and we're also given a given node. So we insert a new node after a given node. So this is our given node. For this example, this would be your new, this would be your given. So we simply go in a while loop starting from the head, and in our condition would be if our current node is our given node. So like here before, this section right here, we do the while loop. So just copy it over. While and does not equal null. And our condition is n equals our given. If that's true, we want to set the given, the next node, to be our new node. So we want to do n dot next equals our new node. And of course, n equals n dot next. But there's an issue here, right? If we simply set it to our new node, we forgot to set the new node to the old node that given was pointed to. So if we just do new node equals n dot next, this is our n, this is our n dot next. What's the problem here? We just overrode n dot next. So this is our n dot next now. So we need to store a reference to n dot next before we update it. So we can do node um, what the and next node next equals n dot next. Instead of this, we set it to next new node dot next. Whoops. So what's happening here? This is currently our n. This is n dot next. First, we store this guy to next. So we put this is next. Then we put n dot next equals to new node. So n dot next equals new node. So this is now our new n dot next. This is no longer, this connection gets broken. And then we set new node dot next to equal this guy. Whatever we store before in the next variable. Yeah. So that's how you insert after a given new node, a new node after a given node. And of course, if that was your whole goal, you can just break over here. No need to keep going and looping for no reason. So that's linked lists. Let's kill everything. Oh, just kill the page as well. Any questions? Okay. What time is it? 50 minutes left. We could either go through the rest of this stuff. Um, although I don't really want to go through that stuff. Um, or there's another practice exam. I think we should do the practice exam and then we can go back if needed. Yeah, it's probably best. So just kill it all. This. Yes. Okay. Okay, so this is practice exam number 2. There are 4 questions. Read the question before answering. Use proper Java concepts. Okay. What is the output of the program? Why is this intended like this? Okay, so we have a string array of items, 10, exam, 25. Just a weird quotes, but and then we're looping through starting at -1 and going through items and I++. So I guess we can start. I'll just put I equals -1. Our item's length is 1, 2, 3, 4. So the length is equal to 4. That's our breaking condition. I is less than 4. So let's see. Going through the first loop, we try this. The answer is parse int items at I. So items at I is currently -1. Can't do that. So what exception do we print? Number format. There's multiple catches, so we choose the catch that represents the exception. And then there's a general catch for everything that's not these two types. So our exception is an array out of bounds because we're going for the index -1. It's out of bounds. So we print out bad array. So bad array. And then we do a finally. Let's go. So then the next iteration, I is now 0. Integer parse int is 0. I is at 0 is 10. So we simply print out the answer is 10. So that worked. Then we go to the finally. So we print out, let's go. I plus plus, I equals 1. 1 is 1 less than 4. It's true. So we continue. So now we're items at 1, which is exam. So the answer is exam. And then let's go. We always print out let's go since it's in the finally block. Let's see. It's gonna be 2 output questions and 2 GY. For the exams that I was given to review, it's just the one I went over before and this, which does not include any tree maps, hash maps, or regular expressions, it seems like. Just GUI stuff, linked list stuff, looping, interfaces, inheritance, abstract classes and methods. Yeah, so linked lists, interfaces, inheritance, abstract classes and methods, and event-driven programming are the topics. Let me just paste that in the chat. Oh, it's too long. Were they given? I have no clue. I don't think so. Yeah, I don't think they're gonna ask for tree maps or regular expressions in 212. Maybe. Uh, but anyways, continue. So the answer to the exam, I was what? I was 1, I plus plus, so I equals 2. 2 is less than 4. So I'll just do blah, blah, blah. The answer is 20. Let's go. I plus plus, I equals 3. 3 is less than 4. It's true. So now we have I at 3, which is 5. Blah, blah, blah is 5. Let's go. I plus plus, I equals 4. 4 is not less than 4, so that's it. We break out of the loop, and this is the output of the program. Wait, 0, 1, 1, 2, 3, 4. 0, 1, 2, 3. Yeah, nice. Am I missing something? Um, plus is 4. No, I think it's should be fine. This answer key is not right. What the hell? Uh, wait, 0, 1, 2, 3. Ah, I see. Oh, shit. So, integer parse int at I. We cannot convert a string into an int. So, this is actually an exception, a number format exception. So, this would be oops, and then the item was exam. Same for this guy. Oops, 5. So items at I has to be a number. If it's not, it'll error out. And it'll error out during these guys because those are not numbers. Yeah, getting rusty. Okay, so what's the output when class question is ran? So question alpha array 4. First index is beta 1. 2 extends alpha. Then we have Jesus Christ. Okay, so let's check this guy first. So beta 1. Beta 1, y plus 1 is 4. So we go super 4. Super is alpha. So here it's 4. So we print out I am alpha and x is 4. I am alpha and x is 4. Okay, that's for beta 1. Beta 3. Oh, I forgot. We got out of the super, and we also have to print out I am beta. And y is, what do we pass in? It was 1. Y is 1. That's it. Now for 3, basically do the same thing. Just add more numbers. So I'm alpha, there, comma, okay, and x is what, 3 plus 3 is 6. We'll also have to print out I am beta, and y is 3. Okay, gamma 5. So pass in 5 here. This is gonna be 10. Super is alpha, so this becomes 10, so we do I am alpha. And x is 10. That's done. We go back up to this guy. I am gamma, and y is 5. Same thing for this guy. I am alpha, and x is 7 plus 5 is 12. X is 12. And then I am gamma, and y is 7. That should be it. Moving on. Let's see, linked list. Fill the missing code for the constructor of the singly linked list, which has a head node. Fill the missing code for the constructor. Also these guys, I assume. Let's go for constructor. So what is missing? Oh no, it's referring to this. Duh. Okay. So what? Okay. Constructor. This is a constructor. So fill out the constructor out. String list. So first we need to initialize first. So we can do this dot first equals new. The type is string node. What are the parameters? Um, nothing, because we can't pass in a value. We don't have a value, so that's good enough. And then last, uh, first use string node, and then this dot last. We can just make it to this dot first, since the initial linked list state, the first and the last are reference the same node, and then length is 0. I guess this part is also optional since the default value is 0, but yeah. Part B, fill loosen code for the method prepend, which should add a new node to the beginning of the list, not a new head node. The new node should contain the data given as parameter. So first, let's just create the new node. So string node n, new string node of the value, pass in value. So we want to append, which adds a new node to the beginning of the list. So let's see, let me just think for a second. A new node at the beginning, not a new head node. And we want to set this guy to here and break this connection. Yeah, so when it says beginning of the list, not a new head node, that basically means after this head node, put this new node into insert it. So we do n, our new node. We want to set the next value to the current head node next. So n dot next equals first dot next. So that's this part. Now we want to do this part. So first dot next equals n. Yeah, that's this. But then we also want to do a check if the first node is equal to the last node. If it is, in this case, let's say we have one node and we're adding a new node. Currently, we have first and last at this node. Our function should do this, and then our new node, this should be last instead of this guy. We don't do that yet, so we need to write the code for that. So we can do if first equals last. We want to set last to our new node. So we do last equals n. In every case, we also want to add to the length. So we do length plus plus. Part C, write an equals method for linked list. If two linked lists are equal, they have the same length, and data of each corresponding node are equal. Okay, so let's just say we're giving this. It's one linked list. We're giving another linked list. They're equal if 10, 15, 0. So all the values have to be equal. So these guys are equal. And in the scenario where the lengths are not equal, then these are not equal. So yeah, same length and each data is equal. So we want to go through node by node in both lists at the same time and check if the data is equal at each point. So first we can do a simple check if the lengths aren't the same. So we can do if this dot length. Remember, we're inside the string list class, so this length refers to this string list, and we're comparing it to another string list. So if these lengths are not equal, then we return false right away. And now we can do the iteration parts. So string node. Let's just do, so this variable represents our current head of our linked list. And we want to also have another node which represents the head of the other linked list. So let's just do P and Q. P will be first. Dot next. Let's do first. And then Q is other, not first. So now we want to check while. So now we're doing the looping part. P does not equal null. It's optional to add Q does not equal null, but we know that since they're the same length, if P is null, then Q has to be null as well, since we're both skip or going to the next node every time at both lists at the same time. So we check if P dot the value in P, which is 10, does not equal the value in Q, then we know that we should return false, that they're not equal. So the data, string data, so P dot data dot equals, if they're not equal, we want to return false. And then if this is false, if this if statement is false, we just continue with our regular program. So P equals P dot next, and Q equals Q dot next. And we return true if we are able to exit the while loop successfully, which means that these guys are equal. P equals P dot next, Q equals Q dot next. We check these guys are equal now. These guys are equal. We end the loop. Everything was equal. We return true. So that's that. Actually, this could be, I can make a big, not for this. You're considered the following GUI listener. If the user chooses succeed, as it's saying hooray, you passed, printed console. If you choose fail, then we print out sorry you failed. You just quit. I swear we just did this. Am I tripping? Uh, it's a little different, a little different. Okay. Exam 2 listener implements action listener, Speedo, via our labs. You're never going to use this again, but yeah. Number 2, mainframe. Mainframe equals F. F is main window. So number 2 is main window. Three, we're implementing the action listener. We have to override the action perform method, which is this method. So 3 is action performed. 4, when do we print out hooray you passed? When the item is succeed. So 4 should be succeed. 5, when it's fail, we print out sorry you failed. Sorry, you failed. Yep, should be it. So is there any questions about any of these questions in general? Anything? Any Java questions? If not, then guess we're all good to go. That will conclude the review session.